Pisa Cathedral one day, a young man sat daydreaming, watching a lamp swing on its chain. He noticed that the lamp took the same time to swing from one side to the other, no matter how wide or narrow its swing. This simple observation was to have momentous consequences for science.
Welcome to Great Scientists. Tonight I'm going to be talking about Galileo Galilei. Galileo was the father of modern physics. He was also a man with an extremely abrasive personality. And that personality later in his life would get him into very hot water.
The Renaissance buildings of the great cities of northern Italy, with their Roman arches and columns, tell us much about the merchants who built them. First, they were loaded. Second, they were in love with the classical world. But although the men of the Renaissance revered the wisdom of ancient Rome and Greece, this was the dawning of a new age. An age when many old and cherished ideas would be challenged and found wanting. And the greatest challenge of all came from one man. Today, we take it for granted that scientific knowledge is based on rigorous experimentation, but it wasn't always that way.
The vigorous intellectual life of medieval Europe, after about 1100, was powered by its new universities. Those great institutions of learning, Paris, Montpellier, Bologna, and here in Oxford.
The scientific ideas taught at these universities were all based upon the teachings of Aristotle, the ancient Greek philosopher who was considered to have known everything. But the problem was, Aristotle's ideas had never been tested experimentally. It was to be Galileo who finally put Aristotle to the test, and in doing so, he challenged the very basis upon which the great universities and the scientific philosophy of the day were founded. He was about to upset rather a lot of people.
But what kind of a man was Galileo? Let us consider his early life.
Galileo was born in 1564. His father was a professional lute player, but due to a lack of demand for top lutenists, was forced to trade in cloth. He ensured, however, that his son benefited from his full attention, and by the age of 10, the young Galileo excelled at the lute. Initially, Galileo wanted to become a monk, but his father, who couldn't afford for his son not to have an income, persuaded him to become a doctor instead. So, at the age of 17, Galileo began studying at Pisa University, where he became obsessed with the study of Euclid and Archimedes. By now, he had grown into a large, flame-haired rabble-rouser, enjoying fine wine, good living, and poking fun at people. He loved conflict and confrontation. Once, during a hailstorm, he is said to have openly challenged his lecturer's Aristotelian assertion that heavier objects fall to earth faster than light ones. Indeed, he would become an outspoken critic of the academic establishment and its adherence to Aristotle's ideas.
Wasn't that terrific?
In this portrait, made when Galileo was approaching 70, he looks rather genial, rather good company.
But in fact, Galileo was quite an intellectual bruiser, and the earliest known portrait we have of him, frankly, you could have thought he was a stand-in from Webster's Revenger's Tragedy. He looked a hard character. Gold earring, close-cropped hair, tight ruff round his neck, and a face that looks a bit like...
As an historian of science, I am often amazed that the most momentous discoveries often come from the simplest of observations, and so it seems to have been with the young Galileo.
Legend has it that as a 19-year-old student daydreaming one day in Pisa Cathedral, Galileo became fascinated by the swinging of a lamp on a long chain. He timed it with his pulse and came to realize that no matter how wide or how narrow the lamp swung, the period of time it took to come back to dead center always remained the same.
Galileo wondered why this was, and set off to time a number of other pendulums, using his pulse for a watch. What he found seemed to be entirely at odds with Aristotle's theories. According to Aristotle, the rate at which an object swings is determined by its weight. But Galileo now realized this wasn't true.
Galileo came to realize that if the physics of Aristotle were going to survive, then they had to stand up to experimental proof.
And so it was that he set about constructing a number of ingenious experiments to put Aristotle's theories to the test.
Welcome to the laboratory. Tonight I'm going to reconstruct one of the defining experiments in the history of physics. Galileo Galilei's celebrated experiment of the acceleration of rolling and falling balls. Now, Aristotle believed that heavier objects fell fastest, but Galileo came to disagree with this idea and set up this beautiful experiment of an inclined plane to which he attached bells at regular intervals. And down that slope he rolled a heavy metal ball. Then Galileo released the ball down the groove. But what he found is that the rings got faster and faster.
But how could he measure the ball's acceleration?
Being the brilliant experimentalist that he was, he repositioned the bells, and putting them into such positions that when the ball was rolled against them, the intervals between the tings was exactly the same. Ting, 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 equal intervals of time between each ring. And by measuring the increasing distances between each of those bells, Galileo was able to work out a uniform law of acceleration. And this law applied to any body, be it made of steel or of cork, at any point on the Earth's surface.
This proved that it wasn't the weight of the object that governed its acceleration downwards, but rather an external force that Newton later defined as gravity. In other words, Aristotle had got it wrong.
The Italians certainly know how to make a terrific pizza. But it was at the Leaning Tower of Pisa that Galileo set out to prove for all time that Aristotle knew nothing about the nature of balls.
The story goes that after a particularly impassioned argument with an Aristotelian lecturer, Galileo set out to demonstrate once and for all that objects fall to Earth at the same speed regardless of their weight. He mocked anyone who disagreed with him. In practice, that meant most of his lecturers. He decided to drop 2 different-sized cannonballs from the top of the Leaning Tower of Pisa. This would surely settle the matter once and for all. Clutching his irregular balls, he climbed to the top of the tower and tossed them off. They landed on the ground at virtually, but not precisely the same moment, and the crowd was left divided. No one could agree whether Galileo's balls had dropped at the same time.
Tell me when you get a good picture, Joe.
370 years later, David Scott tried the same experiment on the surface of the moon. By repeating the experiment in a vacuum, Scott confirmed what Galileo had argued.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And I'll drop the two of them here and hopefully they'll hit the ground at the same time. How about that?
Falling balls, swinging pendulums, what does it all mean?
Galileo was overturning 2,000 years of scientific orthodoxy, and he was doing it not just by observing the natural world, but by carrying out experiments with the help of new scientific instruments which he himself was developing.
And he was on the verge of making the tool that would transform the whole way in which we look at the world. In 1592, Galileo came here to Venice, to the nearby University of Padua, where he became professor of mathematics, and there he would lecture on the Greek mathematicians and also on cosmology.
Galileo was living at the height of the Italian Renaissance, that explosion of artistic and intellectual creativity centred in the great trading cities of northern Italy and financed by the wealthy merchants. And like all the great thinkers of his age, Galileo was keen to make a few quid along the way.
Shakespeare didn't write a play about a merchant of Venice for nothing. Venice was the richest city of the Renaissance. The wealth of the East poured through this port, and Galileo recognized it was capable of yielding a wonderful profit.
Galileo was one of a number of brilliant Renaissance inventors, going back to Leonardo da Vinci. These men developed all kinds of ingenious tools, including hoists, pumps, hydraulics, dredging machines, cranes, artillery, mathematical devices, geometrical instruments, military and navigational tools, ships, cannons, levers and winches. But there was one invention in particular which captured Galileo's imagination.
In 1609, Galileo heard of a device invented by a Dutchman that seemed to make distant objects appear close. From his knowledge of the laws of optics, he deduced how to make one for himself. He called it a perspective. We call it the telescope. Venice was the finest glass-making centre in Europe, and Galileo had access to the clearest glass of the day. And from these pieces, he ground and polished his own lenses. And as it turned out, the telescopes he made were better than those originally invented by the Dutch. His first prototype telescope magnified about 8 times. And he first showed it here in St. Mark's Square in Venice, on the bell tower, to a group of Venetian senators. He gave it to the Doge, the head of the Venetian state, as a personal gift, and gave the Venetian Republic sole rights of manufacture.
Although I never actually invented it.
Galileo refined his telescope, turned it towards the night sky, and began to make a series of groundbreaking discoveries. First, he looked at the moon, making detailed drawings of his observations. Contrary to ancient beliefs, he discovered that the moon was not a perfectly smooth ball, but rather a rough, pock-marked planet with mountains and craters. Next, he looked at the Milky Way and was astounded to find that it comprised of thousands of tiny stars, which, since he could not magnify them any further, he concluded must be very far from the Earth. Then, in 1610, he pointed his optical tool towards Jupiter and made an astonishing discovery. According to ancient cosmology, all heavenly bodies rotate around the Earth. But now, Galileo saw what appeared to be 4 bright stars moving in a peculiar pattern around Jupiter. After 7 days of observation, he concluded that they must be moons in orbit around the planet. Once again, the ancients were wrong. These astounding observations were described by Galileo in one great work.
Today's reading is from Galileo's Sidereus Nuncius, or Starry Messenger, the book that changed the way in which we thought of the universe. And what Galileo tells us here is something that's not only completely and originally new, but where he reminds us that no one had ever seen these things before in the whole history of mankind. He says this, for instance, about the moon. Let us speak first of the surface of the moon, which is always turned towards us. The moon contains many spots and dark areas, and these spots have never been observed by anyone before me. And from my observations of them, oft repeated, I have been led to my opinion, which have I expressed, namely that the moon does not have a smooth and even surface, nor is it perfectly spherical, as many ancient philosophers have led us to believe. The telescope had opened up the cosmos, and Galileo was making new discoveries almost every day. But it wasn't just at night that the telescope was revealing these new secrets. To his surprise, Galileo discovered dark patches or spots on the surface of the sun, and he found that by noting their positions each day, the sun must be rotating on its axis, and made one complete rotation every 28 days. The discovery of sunspots contradicted the teachings of the university academics of the day, who held to Aristotle's philosophy of a perfect and unblemished sun. And this discovery would eventually get Galileo into a lot of trouble.
Every single one of Galileo's telescopic discoveries seemed to undermine the accepted view of the universe. This view, which was deeply ingrained in the academic establishment of the time, was based upon the work of Aristotle and the ancient Greek philosopher Claudius Ptolemy. Now, Ptolemy argued, from the best evidence of the day, that the Earth was in the center of the universe and all the planets rotated around us. The trouble was, the planets didn't seem to move in a regular orbit around the Earth. They would speed up and slow down, go forwards and then backwards, and generally misbehave. Galileo was convinced that Ptolemy and Aristotle were wrong, and instead was drawn towards another highly controversial theory of the universe. A generation before Galileo, the Polish astronomer Nicholas Copernicus had suggested that the movements of the planets might best be explained if it were assumed that the Sun, rather than the Earth, was at the center of their orbit. It was this seemingly peculiar view of the cosmos that appeared to be borne out by Galileo's dramatic new findings.
By 1610, Galileo's telescopic discoveries had turned him into the world's first internationally famous celebrity scientist. He was now wined and dined by the most influential people in Italy. These included the intellectually active cardinals and even His Holiness the Pope himself.
However, his fondness for controversy would sorely test his favour with the Church.
In 1616, Galileo was given his first warning by the Church that he shouldn't teach the theories of Copernicus as truth if he couldn't prove them. Over the next 8 or 9 years, however, Galileo starts to put together the book that would get him into trouble. This book was to be called A Dialogue on the Two Chief Systems of the World, It was set as a dialogue between two men with an equivocator or a judge between them. One man defended the Copernican theory, the other man defended the Aristotelian ancient theories. And over the course of the dialogue, the Copernican keeps winning, hands down.
In those days, everybody had to have their books censored before they could be printed. But Galileo was sufficiently influential that he was able to pick his own censor. And being a rather crafty chap, he picked one whom he knew very little about astronomy. Galileo's provocative book contained the kind of abusive Tuscan vocabulary for which he was justly famous. Words such as idiot, simpleton, mental pygmy, and ass. The pontiff was not amused. Galileo had met his match. For a time, his book was even banned. In his old age, blind and under house arrest, he continued to work on the problem of applying pendulums to clocks, dictating his ideas to his attentive son, Vincenzo.
Galileo was put under house arrest, but it was a fairly open-ended house arrest. He made several major discoveries there. He received a number of foreign visitors, and he died peacefully and in the full sanctity of the church in 1642. Galileo was the world's first celebrity scientist. He was the first person to show that instruments were essential to science. And the most important instrument he used was the telescope, because it, quite simply, changed the whole perspective by which mankind would look at the universe. Good night.